Welcome to the CGVR Study Lab's thesis preparation video. In this video, we're going to talk about research and development. Now your thesis plan might look something like this. So you have your thesis deadline, this is in May, and you might spend pretty much all of your time implementing some piece of software or implementing your practical solution of your thesis. And then at some point in April, you will find that you need to write something as well. So you put something together, and when the deadline comes, your supervisor is gonna say that these statements need some references. And when the reviews come in, the opponent also says that, well, why didn't you look at these books or these papers? And then you basically do your research after your thesis is already submitted for your defense. So as you can see, this is not a very good way to manage your thesis work. Instead, it should look something like this. So you start with some research, you will see what is out there, what are the best practices, what is relevant for your particular thesis. Maybe you do some implementation based on that, but you also write about that. You write about what you found and how you implemented it, or how you used it in your practical work. And I recommend doing these small iterations where you work on both researching new things, implementing them, and writing about it in parallel with small iterations. This ensures that when you have your thesis deadline in May, then your thesis text is well supported and actually describes what you implemented, and all you have to do is format it. Now in this plan there isn't anything after the deadline, but in reality you might also see that you need to implement some bug fixes or do some additional research based on your opponent's questions also after the thesis deadline. So that is okay to prepare some additional things for the defense. And often that is the case, where the opponent still finds some new reference you haven't cited and asks you, like, how does that relate to your work? But that is fine as long as you still have solid support from your own research for your thesis. Doing it this way also ensures that you are making steady progress on your writing and implementation and research, and that you're not implementing a lot of things which you later find out that should have been done differently. That is a risk in this thesis plan where you do a lot of implementation, you write about that, and then at the end you find out that all of your implementation, which includes the design, the testing and all sorts of things, should have actually been done differently. With this iterative process, you will find that out soon. You will do your research, you will see that, okay, interviews are a good idea to do here, or a usability testing is a good idea to do here, or your game design should be approached with these principles, or your implementation should use these programming patterns, or whatever the case might be for your particular thesis. Also, writing about it as soon as you do that work gives you a sort of a sanity check. So if you're able to write about it in a logical way, then most likely it is logical. Furthermore, your supervisor can see what you've wrote and give you additional pointers right away. Now, let's have an example. So you do your research, you find your citations, you maybe read some books, you find some papers, maybe you find Shell's The Art of Game Design book. A very solid reference if your thesis is about game design. Now you use those citations in your implementation. You use what Shell wrote in The Art of Game Design, or you use whatever other sources you had. Maybe you found out that interviews are a good way to investigate your target audience. So you use those interviews to first establish your functional requirements for your product. Whatever the case might be, you're using the research or found citations, the best practices right away, so you can be more confident that what you're doing is actually solid work. Now, when you're doing it, you should also document it, or in other words, you should write about it. And this is not just documenting what you're doing, but this is about writing what Shell described in the book, The Art of Game Design. Also, what other different sources are there about game design, and why did you pick this particular source, Shell's Art of Game Design, and why not some other source? So you're analyzing your sources also critically, you're bringing out what is relevant for your thesis, and how you're using it to implement your product. Now, this very much depends on different types of a thesis, so let's look at the individual types separately. First of all, the author software solution type. So, your research might include the market and target audience research, the discovery of domain theory, papers, books, like we had an example about game design, and also your goal formation and your validation methodology. You're making a software product, so who is the target audience and what need does your product satisfy? This also specifies your validation methodology. So if you're, let's say, making a game that needs to have a retention rate, so you're designing a game where players should come back on the second day, on the third day, maybe a week from when they first played the game. So you need to be able to track the users, how much time do they spend in the game, and how often are they coming back. That will be how you validate the goal you proposed. So you try to make a specific game that has a specific property, and now you're measuring that property. Of course, the implementation, based on what you found through your research tasks, is using the domain theory, the papers, the books on the software product you're making. You're, of course, designing and developing for the market, for the specific target audience you researched before, and, well, your result validation and analysis. Your actual measurements, did your software product satisfy the goals or not, how much, and what can be done to improve it, or what went wrong. So this is quite important. You don't have to succeed, but you have to be able to critically analyze what did you do, what was good, what was bad, what can be improved, and so on. Now, in an experiment type thesis, the research could be about the different potential technologies. So it depends on what are you experimenting with, but usually with an experiment type thesis, there is some sort of a problem, and you're trying to find the best software or a combination of that software or hardware to solve that problem. So your research starts with finding out what are these different potential technologies, what are their pros and cons. The second point is exactly the same as before, and in the third point, instead of validation methodology, you have your experiment methodology. So how are you measuring the success of these potential technologies given the goal you have? And this can be a lot of different things. For example, if you're using human subjects and you're testing your different potential software on actual users or people, and then let's say you have 3 different software you're trying to test, then are you having a single participant test each of those 3? Or are you having each participant test only one? And there are very specific pros and cons on why to do it one way or why to do it the other way. This is something you need to find out and learn and describe in your thesis, but it all starts from researching these different methodologies. Of course, now you have your implementation, you are actually developing your experimental setup, you're conducting the experiments, takes a lot of work and has to be done rigorously, and you collect your data from the experiments, you analyze that data, and you make your conclusions. User manual. Well, your research is pretty much the same as before, but now what you're making is some sort of a guide or a user manual. So you should also research about different methodologies on how to write or illustrate or convey some information to new users of a specific software. Now it becomes a little bit loose, but the implementation could be experimenting with the chosen technology. So maybe it's a new technology, there isn't a good user guide for it, so you're experimenting with it, you're trying out different things, maybe you're writing some tutorials, but to write a tutorial you first need to make the result of the tutorial yourself. So this is what you might be doing when you're implementing in the user manual thesis. Of course, there is some sort of a validation method that you should also have. So actually validating your written user manual or guide should be part of your implementation or your practical work. Just like in the previous types, let's say the outer software solution, you validated your particular software solution. Here you're validating your guide. And of course, a large part of this work is also writing the user manual or the guide itself. So this is an object that is produced in your thesis. It's not the thesis itself, as you can see from the icon. The actual guide is a separate document than the thesis itself. So writing it is kind of the implementation or the creation of that object in this type. Learning materials. Pretty similar to the previous type, but now you're expected to learn about different didactical methodologies. So how to teach a certain field, what are the different options, what are the pros and cons, and you need to use that theory to justify your own choices. Implementation or the practical part is using the created materials to teach, and of course collecting and analyzing the data from the actual teaching. And here as well, you need to create also the learning materials. Now I've written here writing, but this could very well be videos, different tasks, illustrations, and so on. So actually creating the materials based on the didactical methodologies you researched, and well, using those materials in actual teaching. Just like we can see from the icon, there are some materials you created, and you're using those materials to teach some specific field to actual students. But please keep in mind, this is all based on the research part. So what is the theory of teaching, these didactical methodologies and so on, that your actual teaching and materials are based on. Article review. So here you are expected to do thorough research on the chosen article. So you pick one article and you actually do very thorough research about what are they doing, what is the theoretical background, why have they justified the different choices there, and what are the implications of that. Also, the analysis of the article result and your result. So in this thesis, you are taking one specific paper, one specific result, and you're exploring it very thoroughly, trying to maybe improve it in some regards, or at least pointing out what can be improved or what is wrong, and showing that some of the things are not working correctly, or that they are, or that there is another context where they're not. In the implementation, or well, the practical part, you are replicating the article's results. So maybe there's an algorithm that provides some sort of a result, a visual result, maybe doing global illumination in computer graphics. So now you're replicating that algorithm, trying to achieve the same result that they got from their paper, and maybe offering some improvements. But of course, before you're doing that, you need to thoroughly understand what is happening in the original article. The independent research type. Well, you again go thoroughly through some specific domain. You specify some goal, and you are now creating a new algorithm. So this new result, this algorithm synthesis, is actually part of this theoretical research part. You need to go into the theory, see what options there are in the theory, what different things could be done and how. And based on that, you should be able to justify your choices. When you're doing your demo app or implementation, which is optional, then that is just an application of the algorithm you synthesized in the research phase. So in this particular case, the research focus makes up a large part of the thesis, but you can still kind of section it differently. So what is the background theory, what is the specific algorithm, what is your synthesis, and work on those maybe in parallel. For a survey type thesis, the research again is pretty similar to what we had before, discovery of domain theory, goal formation, but now it's also survey methodology. So how are you finding the objects that you're surveying? What are the filters there? So are you including some objects and excluding some other? Why? What is the replicable methodology there so that other people could also find the same objects that you found? The data collection, so you collect that data, and your data analysis. Very important. You collect some data through a rigorous methodology, that is your survey methodology, and you analyze that data. For this type, I have also explicitly stated the writing part here. So this type should have your new and useful categorization or overview, something you produced. But this is based on the research that you're doing. So you're finding the survey objects, you're collecting the data, you're cleaning the data, you're analyzing the data, and based on the data, you can create a new useful categorization, or provide some useful insights, or explore the landscape of these objects in a useful way. Now, when you're working on your thesis, there are different stages. We saw that I recommend you to do research and practical work and writing all in parallel. So a little bit of one thing, a little bit of a second thing that's influenced by the first thing. So try not to go too in depth with only one thing, because all of those things affect each other. But when you are working, you should document the different stages. For example, if you have your outer software solution, you are faced with some sort of a problem, you are ideating on that problem to find potential solutions. Maybe you found that ideating with different methodologies or specific methodologies is a good idea from a source that you found. So now you should document that process. So if you're using, let's say, crazy eights or storyboarding or mind mapping, you should record what you produced in that stage. The results of these things should be included in your thesis. So let's say you did crazy eights. So you should take a picture of your crazy eights paper and include it in your thesis. Or maybe you did some interviews with the target audience, or you did some brainstorming with your supervisor. Whatever the case was, there's some sort of a documentation, some sort of a result. So when you're doing brainstorming with your supervisors, you probably have some sort of a Google document where you write down all the different ideas, or on a whiteboard. So take a picture of that whiteboard or a snapshot of that Google document and include it later in your thesis. So you can write that at this stage you did ideation with these methodologies. You found that these solutions might be potential solutions for your given problem. And we also had other options we considered, and these are in the appendix of your thesis somewhere. For example, here is a picture of some sketches of different ideas for the reflections project. So this was a thesis where the student created interactive visual art. And to come up with those ideas and discuss them, she sketched those ideas and discussed those with her supervisor and colleagues. And these are the sketches. Not all of those ideas ended up in the actual product, but well, 2 of them did and 3 of them didn't, but there are still sketches of these that these two that made it were not the only ideas that were considered. And this is very important. Or, for example, here, this is from a thesis where the Plastronaut game's user flow needed to be improved. And this was one of the potential improvements. So this is just a regular sketch. So you have your character, they're shooting a laser to a plant, and new plants spawn at the new locations. So this is this spreading grass concept image. And again, it's very important that you save this image and include it in your thesis as part of your work progress. Or, for example, here, so this is from a thesis where the student created a web page, a landing page for the Plastronaut game. This is one of his early prototypes, paper prototypes, what should be on the page. So there is some sort of a call to action. What are the different things of the game we want to show on the page? There is supposed to be a buy now link somewhere and a press kit link. So a very simple paper prototype, but already something that can be used to discuss with the supervisor or the target audience that, look, we are trying to make such a thing, what do you think about it? And also used for improvements. Of course, you will also include the later implementations and iterations and what was changed and what was fixed and what are the final results. But these are these early concepts that I recommend you to also include in your thesis to showcase how did you make the progress, how did you start with the progress and the design, and how did it go. It's also very useful to take screenshots of your work in progress. For example, here is a picture of an initial building model and a changed building model. So there was some sort of an initial state and there's a change state. And there could even be more iterations on this. But if you don't take those screenshots often and early as possible, then you might be developing your product or software or thing onwards, and then it might be very difficult to get back to the previous state to make this comparison image. And here is another example from an actual thesis. So on the left there is this early prototype or early version of the game, but the final game was different. So the student took some screenshots of this early prototype before they developed it further. And on the right, there is even a comparison of this old factory GUI and the new factory GUI. So there is this old GUI, so there were buttons and things and cubes, and there is a new GUI where there is this pyramid shape and the button layout is changed. And the student explained in his thesis why did he change it and what were the issues with the initial version, because he tested it on actual users and then found out that, it's problematic, people don't understand the buttons, they don't find the buttons, the cube is problematic and so on. And then he improved it and this was the later version. Please also keep in mind that you should document your testing environment. So if you go somewhere to test, often it should be a rigorously controlled environment, but sometimes it is not. For example, in the middle here we have a school with some school kids. So that's not awfully rigorous. The school kids could talk to each other, make jokes, have a good time, so not very rigorous, but that is also fine. In contrast, you can have a rigorous environment, so in the lab, you could book the lab, and this is a controlled environment, there's no one else listening or distracting the actual users. Or you could even have a small cabinet where you have your computer and your setup, and you ask the person to come there who is going to test your product, and it's very distraction-free environment, controlled environment. Nothing crazy is gonna happen there. With school kids, probably something crazy is gonna happen there, but that's still fine. As long as you remember, take a picture of the environment, where did you do your testing. But you also need to document your testing results. And this is something that students may forget, especially when they're testing at expos. So this is a picture from an expo. There is this game Downfall, which is a master's thesis, and the student showcased it at the Games Convention Expo. He had an online forum where participants could give feedback on the game, but he also observed them, how are people playing the game, and of course lots of visitors gave him verbal feedback. So he had a notebook where he wrote everything down, so he documented everything in writing, the verbal feedback he got, what he observed people doing, and so on. So at the expos you need to still have some sort of a way to document what did you observe. And we have had cases where the student has lost an entire grade in the defense because they didn't document their testing results that they did at an expo. So expo, it's because it's not that rigorously controlled. This idea that you still need to document what you find might be something that you forget. So please don't forget it. Now the takeaway from this video is that different types focus on different practical work. We saw very different practical work, but regardless of the type, they were very closely tied to the other parts. Concurrent, research, implementation and writing. So when you're implementing something for a long time, please think about it a little bit and make sure that you have not gone into a lot of implementation without actually doing your research or writing about it. Because when you're doing your research and you're writing about it, you get better ideas and better support for your implementation. It could be the other way around as well, that you keep writing or keep researching without actually implementing. So small iterations and concurrent research, implementation and writing. Do everything in parallel a little bit. And lastly, document and include the different stages. Document your early concepts, your ideation results. If you're doing early testing, document that. Take photographs of testing environments. Have a notebook where you write everything down so that you will have things to include in your thesis about the different stages of work that you did.